Hi, my name is Daniel Pistelli, and in this video I'm going to show you my new application, Native Blocks. The reason why I'm doing a video is that I don't have the time to write an article. Since this is sort of an unusual application, I'm going to start directly from the interface. If you want to define it, it could be defined as a reassembler. As you can see, the interface starts with 3 buttons and it supports currently only .NET, but other technologies are going to be added. If I click on empty, it opens an empty interface, of course, and as you can see there's an editor and a blocks tab. The editor is a compiler, so I could write code in it. And compile it. The blocks interface is an analyzing interface. I can transfer the compiled output of the editor to the blocks interface with just this button. It gives a better view of the code if you're analyzing something. The commands on this interface are very easy. These 2 buttons are undo and redo operations. These are for zooming in and out, and this restores the state. This button takes a screenshot of the view, and it comes handy if you want to embed an image of the blocks in your article, something like that. This button we're going to use later on. It just transfers the code inside the blocks to the editor. In this case, it just tidies up the code, as you can see. The buttons on this interface are also very easy. This one compiles the code, this one compiles the code and transfers it to blocks, and this one transfers it and does not anything else, doesn't do anything else. This executes a script. The scripting feature we're going to see later, and this button is useful to get the compiled output. We could get the output in the form of bytes, or save the output to file. In this case, if we click on from bytes, it takes an input as input a byte sequence. So we could for instance take a .NET method and put its byte sequence in here, and it opens it. But in this case we're going to use a rebel.net file. If you're not familiar with rebel.net, it's a tool which stores, it has 2 functions. The first one, it stores all methods and streams of an assembly into an easier to read file format. We're going to open that file format to edit the methods and use then again rebel.net to rebuild an assembly. Later on, Native Blocks will support the opening of .NET assemblies directly, but for now we're using rebel.net. So we're going to analyze a method by reflector. I chose reflector because it contains a good obfuscation, so we're going to use this tool. It's not like I picked the first assembly which came to my mind, and it has a good obfuscation. I think I know what the obfuscation is called. I'm not entirely sure, but I won't say the name anyways because I don't want to trash a commercial obfuscator. I'm just going to I chose it just because it's a good obfuscator, in fact. Okay, now create a report. Now I can open the rebel.net file from the native blocks application. I'm going to a method which I know is well obfuscated. So, as you can see, this is the same interface as before. I'm going to make things very short. Basically, in this method we can see the structure. It has a giant switch block. You can see it. I know this is a YouTube video, so this is a switch block, a giant switch block, and the code uses the switch block. You see it loads the variable 16 in order to transfer the execution to another part of the code. So if we find something like, for instance, this syntax, it loads the number 31 in the variable 16 and then jumps again to the switch block, which in turn evaluates the case. In this case it was 31, so 31 jumps to block 13. It means that after this code is being executed, execution will be transferred here. Okay. In a few words, sorry. In a few words, it means that basically we can replace this block with a simple branch. The giant switch can be removed, and this code, this sequence of instructions can be replaced by a branch to block 13 in this case. We're going to do this by using a script. As I said, my tool supports a scripting feature. In this case, the script we're going to use is JavaScript. As you can see, I'll show you this script. The first part, it parses the giant switch at the beginning. It just puts each case in an array, and from that array you can retrieve the block which is going to be used to be jumped to when a certain case happens. This is the main code. It just goes through every line and searches for the given pattern. Okay. As you can see, there's no longer the giant switch. We'll see what happens if we see it from the blocks interface. I compiled the code, as you can see. And now we have this case where an unconditional jump directly jumps to another block, a contiguous block. This is what I call contiguous branches. It's a direct result of removing the giant switch, so we need to remove these contiguous branches. This is a very easy operation, and as you can see, even the script for it is very, very simple. I just show you the script. Very minimalistic. Okay.